Hello, everybody. Good evening. It's just gone 8 o'clock here in South Africa, and this will be my first stream of the year. What is it, the 12th of January? So a little later than I think I had intended, but here we are. Let's start the year off. So today I am actually going to be working on my university projects. I have got to finish up two Unity scenes for a deadline on Monday, so I'm going to have to crunch a little bit over the weekend to finish that up. And you can choose 2 out of 3 projects, and I've chosen to do a 3D scene based on primitives and a physics-based scene. And I have no idea what I want to do for the physics-based scene, so I still have to come up with a bit of an idea for that as well. But before we get into any of that, it's the 12th of January, and there's already been something like 2,000 layoffs for the start of the year. So that is crazy. That's really, really wild. I did learn about an interesting, or not so interesting, thing that has kicked in at the end of last year. And that is I think it's that's actually the end of 2022. So it kind of slipped through, and I think everyone is starting to feel the pain of it coming this tax season that's coming up now. But basically, in the US tax code, as part of the Trump administration's tax cuts, they instituted a change to sort of help balance the books, which would in essence, it would force you to amortize your R&D spend on salaries, on developer salaries. So now all of a sudden, if you're a software company, a SaaS company, or a game studio, all of your engineers and designers, developers, they're all considered now an amortized cost and no longer a direct cost. And you have to amortize this over 5 years with it's actually 6 if I read it correctly, with the first 10% in the first year, and then 20 and 20 and 20 and 20 and then 10 again. And what that means is that if you were to spend $1 million on making a game and you made $1 million in revenue, then you would be liable for the tax on the difference between the $1 million of revenue and the $100,000 of amortized cost. So you would be paying tax on the $900,000 that your company now made in future revenue. So that is, I think, quite a impactful thing. Anyway, let's hope that the powers that be fix that and change the legislation to be a bit more R&D and startup friendly, because this is especially challenging for startups. Hopefully this doesn't make it even harder to start businesses. Okay, so what I have made is I made a parking lot diner, or a diner with a parking lot. I just really kind of threw this together. There is, and I have some code for that somewhere. There are some cubes around the edges, I think. Here we go, edge colliders. Okay, there they are. That was just so that you can't run off the edge of the map. I'm not really fond of the default Unity skybox, but I'm probably going to just leave it because there's too many other things going on here that I need to deal with. I'm not going to stress myself over the skybox. And then I used Adobe's generative fill, so don't shoot me for using AI art stuff, to make the asphalt texture, as well as the brick texture that's on the walls here. And to make a sort of a metal texture. It's not and the floor texture, so it's kind of a metal texture on the legs and on the table counter underneath, etc. And then this sort of oopsie, that was the wrong way, this sort of mosaic-y looking floor texture. This is the Eve model from Mixamo. and I've just got her in the scene so that I've got an idea of scale so that it's not completely out of whack. You can see that basically these are cubes, all cubes, and then all cubes, and then a couple of cylinders and all cubes, and then I used some area lights and some spotlights, and I used an emissive material to make the light sort of panels shine. And I think the scene came out pretty good. I'm by no means an environment artist, so once again I'm just trying to get a mark for a degree purposes, and that's where we are. So what I want to try and do tonight is just add a little first-person controller to this scene. My Eve character does in fact have a player controller attached to her, which I built for a previous project. So I'm probably going to use this player controller script as a starting off point, just because it's already got a lot of the wire up for the input system, etc. And I think it actually works. I haven't actually tested whether it does work. I think it works. I might have tested it. Let's quickly run it and see if it actually does work. There we go. Now this will be the, we're in the camera. Oh, let's see. Oh, there she goes. Yep, so that controller works, which means that all our input stuff is firing. And basically that means I need to take a look at the player actions and the events. So where are the events? Player events. There we go. Alright, so I am going to disable the player input here and the player controller, but I'm going to use this as my sort of guiding star to make a first-person controller. So where we're going to start is I'm going to create a new empty, and I'm just going to call that FPS player, and then I'm going to move the camera into that new empty, and reset the camera's transforms. Okay, there we go. And then let's bring this out to a sort of starting off point, so you can, when you start, you can look at that and that and that. Okay, and then I think I'm going to bring this up a little bit to like 1.8, so basically 6 feet tall, and if I remember correctly it's Control P to start play mode, and then our camera should now be there. Okay, I don't know if that looks right for an FPS, but that is what we've got. Okay, now we need to add to this a input. Okay, so I'm going to come here and I'm going to go see if I can just copy this component and I can paste it. No, it's not going to let me paste it. Alright, so let's just add a player input. Okay, I'm going to, I think I'm actually just going to create new input actions. Let's see if this makes a difference if I use that camera. I'm not going to use things like the Unreal, Unity. See, now I've been using Unreal for so long. I have forgotten all about how to say Unity when I'm working on Unity. I don't know if this, it's MIA. Yeah, or it's actually closed now anyway. I've now been saying Unreal for so long that I'm struggling to say Unity. I don't actually know where that's going to do, but we are going to use Unity events, and then we are going to add script, so we're going to add another component, and we're just going to call this FPS controller, and that's a new script. Calling it FPS controller, and why doesn't it let me create and add? The script name only consists of, okay. Okay, I'm going to move you into my scripts folder, and then we're going to go into Unity. Not Unity, Visual Studio, which is opening on a different window, and I'll bring it into focus as soon as it's finished doing its dumb thing. Okay, looks like it's loaded. Where did it go? Ah, there it is. Okay, hello. Alright, so public class, blah blah blah. Okay, so I've got scripts in here that I probably don't need, but that's okay. Alright. Acceleration, turn speed, da 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 da. Do I need a rigid body? This is to see whether I'm on the ground, so I don't need that. I don't think I need that. Don't need, let's see, do I need? Alright. So this is using a little bit of physics to move the rigid body, and then using the speed to tell the animator to apply the animations. None of that is really useful, and so let's just go take a look and see where are our events. Private void move. Just taking the move direction, which is the WASD keys. So now we need to add mouse look. Okay, so let's do that quickly. I'm going to start with that. Let's go in here. I'm going to go do that. And we don't need. Well, we're not going to use any of that. So I'm going to move. Yeah, so I think I'm going to move fairly uniformly. Oh, come now, Copilot. Yeah, I think I'm not going to have any kind of dampener on the acceleration. I'm just going to move you with translation. So all I'm going to do is I'm actually just going to store the movement vector. Store movement vector. Add look on mouse input. And might add an action button opening doors. I was thinking of putting a door on the diner and having the player have to open the door before they can actually enter the building, which means that I need a rigid body. So I need a rigid body, but I'm only using it so that there is a collider, so that there is something to collide against when there are colliders. Okay, so here we go. Let's go and see. Movement and equal to, oopsie, direction, and we can tell this to generate a field. Okay, and see. That's clever. Okay. So something that I told my Visual Studio to do is to add access specifier, access modifiers whenever I save, and that is pretty cool. Okay, so we've stored the movement vector. Now in our update, we need to see now, so we are going to use a rigid body because I think it's just simpler, but we're actually not going to use a rigid body for any other movement. We are just going to say this dot. Why is this not giving me the position? There we go. It's transform, right? I've got to remember all of this stuff. Transform dot position. And okay, why is it not? Oh, because I think it's that. There we go. Alright, so now we are going to move in the X and the Z, and if we minimize that, I just need to save. Let me just actually save all of that first. Let's save that. Okay, and we're going to come in here and go look at our Eve prefab when it's finished compiling. Okay, we'll come to our Eve prefab, and we are going to switch those things off. Okay, then we are going to come to our player, and we are going to add a rigid body and a capsule collider. Okay, now our capsule collider center is at no, let's put it at minus 0.9, radius is 0.5, height is 1.8. Okay, let's go take a look. It's a little big, but that's good enough for government work, right? And we are going to add our player actions because they're essentially the same. The actions are the same, right? And then we're going to go to our events, and we're going to go to our player events, and we're going to go add, and we are going to take from here the FPS controller. Why is it not there? Why is it not showing it to me? What am I missing? On here, on player controller dot on move. Huh. Okay. Either I'm very blind. Oh, yeah, they are. Yeah, they are. Okay, so there's my on move. Alright, so this is what I'm actually going to need. I need that piece. Let me go here. And I'm just going to pop it in here. Okay, I don't know why it was. Top, because I like to put my public things at the top, and that is all wrong, so I'm just going to bring this up here so I know what to do, and I'm going to change you to direction, and then we can take that and that, and that'll fix those two. And I don't think I've made anything in the start just yet, so this is good. And that should be good. We read the value if it's performed or cancelled. Okay. Alright, it's busy loading. And now I can go back to my FPS controller and I should have that on move event available. Okay, events, player events, FPS controller on move. Okay, good. So now, if all goes well, we are going to be able to walk. Now we should walk into the door. Now we need to, yeah, we'll see what happens. Okay, so that did not work as expected. And we just, I don't know, we just rolled, because we're a capsule collider, I think we just rolled off the, off the ground. That's fun. Alright, so what went wrong? Firstly, on our rigid body and our capsule collider, let's just go take a quick look. I don't want any physics materials. I need to switch off constraints. There we go. Okay, so we are going to freeze the. No, we want Y rotation on, but X and Z rotation off. And for now, we're going to freeze the Y position so that you can't jump. Okay, let's see what happens. Okay, so that's very fast. We don't want it to be that fast, I don't think. And unfortunately I haven't enabled that little key mapper thing yet, but I am pressing right, I mean I'm going backwards. I'm pressing A and I'm going forwards. S takes me left, W takes me right. So the problem that we have is that we are translating without taking into consideration the rotation, the current facing of our character. So if we go back to our code, now I've got to remember how to do this. I haven't done this in a very long time. I think I take this, let's say, times by transform dot forward. No, it does not let me do that. Transform dot forward is a vector 3. And it does not want to let me multiply 2 vector 3s. Why would it not let me multiply 2 vector 3s? So what I need to do is I need to get the forward vector and then apply a conversion on the forward on the movement to the forward vector. So depending on which direction you are facing, that is the direction that the move vector must actually be going in. So I wonder if I can do that. Transform dot forward dot x. I don't think that's going to work. And I don't think that's going to work. Transform dot forward dot z. I don't think that is correct. No, that's not going to help me because that's just taking it and actually increasing its size. So how did we do this? I need to first rotate the I first need to rotate the movement vector. So if you're pressing, well, let's firstly just do this, just so that I've got a sense of what I'm looking at, because I don't think I know what that's, well, that's cute. That's a lot of extraneous stuff that Copilot just threw in there. We're not going to leave that in there anyway, so let's save that and let's go back to Unity. Let's firstly just take a look and see what that vector looks like depending on which keys we are pressing. So if we're pressing W, we are expecting to move forward, and forward is in the, what's the blue? Blue is Z, so actually forward is Z and left and right is X. So if we are pressing W, that is probably the Y vector actually. And that is exactly what I think is happening. If you look at it, that is me pressing A, which should be making me go left and right, is hitting the X vector, which is making me go backwards and forwards. So if we go look at the code, we put the X into our X and the Y into our Z, and what we should be doing is putting the X into our Z and the Y into our X, and then we can see if that theory holds while we are rotating the transform. So let's do that. Let's change that to a Y. Let's change that to another Z, X, and save that. Let's go back there. Okay, and what's that? Okay. Oh, now it's going the opposite way that I wanted to go, and left is going left and right is going right. So that's doing the right thing, that's doing the wrong thing. Okay, well, we can start by just inverting it and seeing if inverting the X and the Y actually fixes that problem. Let's see if that fixes that problem. Okay. You're cheating big time if that is the case. Let's see. Say not F5. So used to just hitting F5 when I'm in Visual Studio to run the thing. Okay. Forward is forward, backwards is backwards, but we are able to walk through walls and go into a spin, which is not what we want. We do not want it to go into any kind of spin. So why is it going into a spin if we don't want it to go into a spin? Okay. Could be because we're using a capsule collider. We could just use a box collider, I guess. It's weird. It's interesting. There's nothing for it to collide against, and yet it went into a collision. Okay, that's strange. So let's go take a look at our wall. That's that piece there, and it has a box collider on it. It's not a trigger. So why am I able to go right through the wall, even though there is a collider on it? FPS. Oh, that is interesting. You don't actually need that, and I think we can do that as well. So it's a lot less. Okay. Okay. Oh gosh, that was not what I wanted to do. Let's go do that. Alright. Let's firstly take a look at that. But it should be hitting the collider. I'm curious why it's not actually colliding. Ah, I know why. I know why, because, and then also making it kinematic has also fixed that. Because I'm still moving the game object's translation, so even though there is a collider, I have to use the rigid body for the collision to actually happen. So, sadly, we are going to have to go here and say, okay, PowerPoint start, and rigid body equals get component rigid body. Okay, and that there. Okay, and here let's go. Now let's see if moving the rigid body has the same effect as moving the game object. Because otherwise I have to push the rigid body, which I'm not excited about. Okay. No. Changing the position of the rigid body has the same effect. We are running through the wall. Okay. Okay. Let's see. Okay, force, vector 3 force, and force mode. So that's our force direction, and our force mode is okay. We don't care about mass. Now we are going to take this and we're going to force equals that times time delta time times speed. Okay, and then we're going to add a float for speed. Float speed. Okay, so we'll see whether 5 is fast enough or not, and also going to change this to fixed update. So in Unity, you should do your physics work in the fixed update and not in the update. So let's see. No, no, don't do that. It is trying to trick me. Alright. What are you on about? Okay, reorder operands. So that's an interesting thing that I have no idea why it is more optimal to put the floats in front of the new call unless it unless it operates from the back. So okay, let's go back here and see if we are now getting collisions. Because I'll be really frustrated if we don't get collisions. Also, if we go too fast. Come now, let's go. Oh, it's too slow. I think it's too slow. The rigid body change is too slow. Okay, let's make it faster. 5 is too little, so let's make it 50. And let's see if that works. Let's do this. Serialize field. Okay, so now we have the field in the inspector, which means we can tune it until it's fast enough. Come back to Unity, let's go to Unity, script compiling, oh, out of coffee, but I got water, so I'm okay. I should make an intermission screen. Okay, rigid body, FPS controller script, and do you not have my field? Oh, where is my field? Oh, it's made it read only, that's why. Well, that's daft. There it is. Hello. Okay, so now we can make it faster if we need to. If at 50 is still too little force, it shouldn't be though. Well, I suppose it's now times by delta time, so yeah, it could be too slow. Is it still too slow? Still too slow. Okay, let's make it 100. Still nothing. Okay, let's make it 1,000. Alright, so it's not working. Whatever it's doing, it's not doing anything. Now it's not working. Look at that, that's cute. Okay, so it is not working. Alright, because by now we should have definitely had some kind of application of force to our rigid body. Why is that not working? It can't be because of drag. Definitely can't be because of drag. Still doesn't like that. I could have sworn you can multiply a vector 3 with a vector 3. Huh. Okay, let's see what happens if we do an impulse force. Move direction is still valid, which I should actually just put in here. So I only really need to log it when something happens. Huh. It's very, very disturbing. I don't really want to use an impulse force because then we are dealing with forces. Well, let's see. Let's see what happens. Oh no, that's not going to work. Let's first play it and then we can press buttons. Coffee. Not good. There's something else going wrong. Yeah, because it's definitely picking up the direction. It's just not doing anything. We can also, just for the sake of completeness, we can actually come in here and also do that, take that into here, and then say it's moving, and yeah, that's kind of boring. So we're going to move this to, so now we're going back to the same structure, I guess. No. And I know this is supposed to be more optimal, but I don't like that. Okay, actually I'm going to take the comment, put that here as well, and call the move function every frame. Okay, but that doesn't make sense. So why aren't we speed times time times the direction is the force? Okay. In this one, let's just go take a look. We have the rigid body. We've got our move direction. Acceleration was 400. We added a force transform, that's for jumping. We added a force times transform dot form. The force mode is force. Yeah, so that gives you a gradual increase, and the acceleration is quite a lot higher. So I'm not really keen on going that route. I'm still not really keen on going that route, so let's just go back and check that out. The force is the direction y times move. Move gets called with the move direction, which feels like a bit daft. And then it does a rotation, which is not what we want to do, so that's okay. Times acceleration. Okay. And force is a float. Oh, because yes, because it's actually applying it's applying that to the forward vector. So it says take your forward vector. The forward vector will be whatever the forward vector is. multiplied by the force, which is the size, basically magnitude. And the forward vector is always going to be between 0, -1, and 1. So the force then just is the magnitude, which is basically what we're doing in here. Oh, so that's that one. It's calculating it, and then it is. Now, I still want to use rather a velocity change, I think. Okay. So nothing there, I think, is different, significantly different. There's a couple of small variations to the theme. And now we take our glider. So I just want to take a stab at. Let's make this a little bit thinner. And let's make this a little bit smaller, so it's not actually touching the ground. I can't see that that'll be the problem unless it's rooted in the ground, which it shouldn't be. There's no physics material, so everything should have minimal friction. There's no movement whatsoever, no matter what. Let's just give this speed a ridiculous number, and there's no movement. So this is something is not right with the rigid body. Let's just go take a look. I have told it how to rotate and to freeze its Y position. Okay, let's just undo the freeze of the position, because I can't see that the rotation will cause a problem. Yeah, that's still doing bugger all. Nothing happening. Yeah, nothing happening. You can see that the input is being read, but it is not playing ball. So why is it not playing ball? Tell me why you are not happy. What is making you unhappy? It's not colliding with the ground. It's got a weird rotation. Oh shit. Okay, so that is a problem. It should not have any rotation. So let's just zero out the rotation so that it has no rotation. Okay, now let's also see what that does. Okay. Yeah, so it's the camera that we need to rotate the camera, not the body. Okay. Z is going to be at 0, and Y is correct, and X is 5, so X is 5. Like 1.7. Now it's in the ground. Okay, so that we don't want. That's 5 now. 8. Okay, now it's not in the ground. And yeah, alright, that's fine. That's fine. And what we're going to do, just so that we can get the shits and giggles going, is for now I'm going to take this piece out, and I'm going to go rb.transform.translate. Oh my gosh, okay. That might be very fast. Yeah, that's going to be very fast. Let's see what happens. Ah, it's actually going to be fine. It's actually going to be fine. Because you're multiplying by time to delta time, it will apply it'll be 0.02 times 50, which is 1. So it'll actually be the same. Okay, so now we have an interesting challenge. Now W is right, A. Okay, so let's reset those XYZ coordinates. Let's go back there and let's go fix my XYZ coordinates. Translate. Blah, blah, blah. Yeah, this is going to be interesting. Okay, let's do that. Okay, let's go back here. Yeah, because we want to rotate. You actually want to turn, not just look. Which, yeah, there'll be time to make it smarter so that there's look ahead in the turning of the FPS. So when you turn, you look, and then you turn your body, right? So not just you don't turn your body to look, which is what I'm going to implement. Okay, forward, backwards, forwards, backwards. Okay, so right. Okay, so that's cool. It's too fast, and it's still going right through the wall. Okay, but at least we are moving. It's just damn fast. But we don't know if that is going to be the same when we stop using the translations. So let me get this back a little bit. Alright, so the camera is facing that way, and that's okay. And I want to still move you a bit like so, and rotate you like, whoopsie, that's not what I wanted to do. Rotate you like so. Show me what the camera sees. Yes, cool. Okay, then actually, while we're in that position, let's see what happens, because now we've rotated. What happens when we press the... Yeah, yes, it's going to go in your direction, isn't it? Yes, okay. So that is going to be a problem, is it? I don't know. We'll see. Okay, I have a solution, and I like my solution. Alright, so we are going to first calculate the force, then we are going to say yes, our direction with direction X no. It's going to be transform dot forward times move direction dot x times force plus transform dot right. Yeah, I think that's going to be the trick. Okay, you want to do that, that's fine. You can do that if you want to do that. And then your direction. Okay. Save that. Wait for it to compile. Come along, Unity. Wow. Yeah, finally. Okay. So I think what I did will work. I'm going to see whether I fall off the edge of the earth. Oh yes, of course, because I actually also don't have working colliders there. Okay, so now we're going sideways, backwards. Oh, this is not good. That is pressing left is taking me backwards, pressing right is taking me forwards, and none of this stuff is working the way that it should. Okay. Why is that? Heaven only knows. Okay. It's adding up the two vectors, which is correct because it's saying you take the x times the force times the forward vector plus the y times the force times the right hand vector. So, which before that was what we had. Yeah, that should work. Right, it should work. But it's just translating. Okay, so what we really need is for this to work, and I cannot actually fathom why it's not working. So why is that not working? And once again, I wanted to press F5 to run the code as opposed to saving it so that Unity can take 10 minutes to compile and then run it. Huh, that's so weird. Okay. Nothing. No movement whatsoever when we apply a force to the rigid body. So why is that? Why is that? That's good. But first, before we take a look at that, we're going to take a look at Eve. She has a rigid body, and she has a capsule collider, and she has her controller. And that is all. And the rigid body is frozen there. It's not frozen there. It has no drag. This one does use gravity, but I don't think that's necessary. It does not exclude any layers. So there's nothing significantly different between these two. This one does not use gravity. This one is set to be use kinematic. So let's switch off the kinematic and see if that is the problem. And let's increase the speed. To see if that is the problem. Now we change two things at the same time, so we won't know which one is the actual problem if it starts working. Whoop, and we go off the edge of the earth, and we went really far off the edge of the earth. Okay. So we went off the edge of the earth, which means that our directionality isn't right yet, but the kinematic was the problem, and that is why it wasn't moving. So now we can hopefully slow it down, and then we can figure out how to get it to move in the correct direction. So let's see. Okay, when there's no pressure, you should be stopping. Oopsie, oopsie, and it just keeps on being faster and faster until it moves off the edge. Okay. Okay, so first things first. You are okay, so this can come out, and I use the velocity change. Let's try it with an impulse, because an impulse will just bump it in the direction. So maybe what we want to do, we don't know. We'll see. The directionality is still a problem, but let's fix first things first. Okay, so first things first. Alright, there we go. Okay, so, okay, well, it starts moving. Oh, right, it's applying an impulse to it, and then it stops it. It applies an impulse to it, and then it stops it. I'm still using, this is left, this is right. So right currently is moving me forward. Okay, well, let's see if we get a collision. Yes, we managed to get a collision. Okay, we don't want to go spinning off into space once we have a collision. But it looks like something. It looks kind of cool. It just might be nauseating after a little while. Okay, so what is wrong with the directionality of this vector before we try and fix the getting flown off into space part of this conversation? Okay, let's try the directionality. Do we want an impulse or do we want a velocity change? We don't know. Okay, go into Visual Studio, and if you are not moving, you should be set to stop. So let's go take a look at you. You're saying fix update, move in the move direction. If you are moving, okay. Okay, so if you're, what we're currently doing is we're adding forces when we are pressing keys. And what we wanted to do is we wanted to stop when we are, so we wanted to stop when we have reached a certain speed. So firstly we need to set some form of maximum speed. And this one is using a much higher acceleration, but that's because we're using a force, not an impulse, and the weight is, the mass is also quite a bit lower. So let's fix a few things in this controller. Firstly, let's move things that we don't need out of the way. We're going to change the speed. Okay, so the speed is, I'm going to change this from speed to acceleration. I'll let Visual Studio fix that for us. And then we're going to add a serialized field, and we'll call that max speed, and I'm going to make that 5. And then we're going to come in here and let's just see. Okay, we are going to say, let's try that. Let's do that and move direction y times transform dot right, and direction can be taken out. And let's say if we're moving and the rigid body's velocity dot magnitude is less than maximum speed, and oops, this is also wrong. Okay, so let's say if the magnitude is less than maximum speed, and else RB dot velocity is vector 3.0. Okay. And now also going to say, this is just a cheat to that's a cheat to stop the rotation when you've hit a collider. But might not. See, when you use too many shortcut keys, it might not prevent it from going into a bit of a spin while you're running into the wall. So as you run into the wall, it might go into a spin, and when you take your finger off the keys, you'll stop going into a spin. We hope. Now let's see if the force mode's being applied discretely as opposed to as a summed up vector. I can't see why that would not work. That's still going sideways. That is so bloody annoying. But look at that. Okay, so it's walking, sort of, but it's walking in the wrong direction. Why is it walking in the wrong direction? Why are you walking in the wrong direction? I start you off with some rotation, but that shouldn't. Because I mean that's your forward vector, isn't it? Isn't that your forward vector? Huh. Okay, so let's just add some logging so we can see what the forward vector actually looks like, because it's definitely it means that my earlier thing was not wrong. So which is incorrect. Okay. And what we want to do is we want to say debug.log direction forward there, transform.forward and right and transform.right. Okay, let's see what that looks like. Just give us an idea of why the directionality is all messed up. Okay. Right, now we have let's see direction minus 15, 99, minus 15, 99. That's literally the x and the y are swapped. Huh, well that's interesting. The x and the z are swapped. And so the direction is okay, of course, because we've hang on. Alright, we are still moving in x. Moving in the x. Okay, that is bizarre. X. This is now me pressing left, right, and it's moving forwards and backwards, which is correctly. Okay, so is there a reason why it's doing that? Okay, so we can see that it is minus 99, minus 99 and minus 99 the whole time, and then that's moving it forwards and backwards. So let's just reset this thing's y rotation to 0. Okay. Oh, wow. Okay. Our move direction was okay. I feel like I'm getting somewhere. Let me just change that. So blue is Z, and Z is forward. Ha, and X is right. And so we were correct to do this. Take that and that, and then do that and that, and then do that. This is X. Okay. So what was wrong? The forward vector is actually in the z direction, and the right vector is in the x direction, and the y vector is in the up direction. And so now forward moves forward, which is the y-axis of the controller, if you will, and left and right moves me left and right. So to prove my theory, I'm going to now once again rotate the player object so that it's actually looking at the dyno, and then we'll get to the, let's just see, let's just let the camera see. Yeah, that's cool, that's what we want. And if we now run it, look at that, and then we crash into the wall and go backwards and forwards. Okay. Whoops. Oh, that was collisions are a little bit rough. Okay, that's interesting. It feels like okay. So what is a little bit of a problem is if you're already going at max speed and you change your direction, then it just keeps on going in the direction that it was going in, because it's treating all velocity as one thing. So that's a little bug in here where I'm checking to see if the magnitude, if the velocity magnitude is less than the max speed. And how am I going to fix that? So it's adding an impulse force and it's keeping to the maximum force. So okay, so that's an interesting problem. Let's think. Because we need to be able to change the direction even though you are at the maximum speed, right? Yeah, that's the problem. You need to be able to change the direction even though you're at the max speed and you're moving. So how do we deal with that? We need to be able to change the direction without Now if you add an impulse force and there's no friction, then it'll never slow down. So you can't use friction to help you, because we're saying we're explicitly not using friction. This is an interesting problem, because we're not using friction, so we're not slowing down. So you can't use friction to keep you under control. You have to somehow keep on using velocities. But you have to be able to say that your maximum velocity, so you need to still handle the directionality change. So you mustn't add any more, you mustn't increase the force. Maintain the force every time. And even, so also just because I want to now test on the theory. Oh, of course, in order for you to change direction to go forward, you actually are going to need to lift your finger off the key. So we shouldn't be using an impulse, we should be using a velocity change. So we should be using velocity change, and velocity change ignores mass, and so we'll ignore everything else, but that actually means that this is no longer going to be a actual force. So I'm going to take this out and let's just see how that behaves. But yeah, what that means is it's no longer an actual force. It's just a pure velocity change. So you need a higher number, and that number needs to give you a constant, some kind of constant speed. So you're immediately at speed. It's an immediate speed, and it must be a constant speed. So we may need a higher number. Let's just be on this player, so we can change that. And we might change it back from acceleration to speed, because then it is in fact speed, and we're not really using maximum speed. So, but let's see what happens. Because now that is going to be 1. Whoop. And it still hits. And okay. And it goes off the edge of the earth without. Oh, and now it's collided with the earth. Okay. Alright, so I don't think that worked. That's anyways way too fast. So let's just change that to like a 5. Let's see. I just wanted to be a bit slower. Yeah, okay, that's alright. Whoa. It's not changing direction much. See, once you do that, it doesn't change the direction. Now it's doing it. But when you press 2 keys at once, it's not really strafing. Is it? What is it? Forward vector, right vector. Pressing them together. It is moving. It is moving at a strafe. Lift the key, it's moving to the side. Press it backwards, it's moving that way. Press it forwards, it's moving at an angle. Moving straight. Whoop. Oh wait, it's hitting the collider, isn't it? Oof. Okay, let's get off the collider. Okay, and let's move back at an angle. Let's lift the key. Oh. I think we've got it. So now we need to add the mouse look. So the mouse look needs to change the rotation of the body in the y-axis and of the camera in the x-axis. Okay, that sounds like fun. Okay, let's go take a look at our player actions. They are move, look. Okay, so we have a look. It's right stick, it's delta pointer. Yeah, okay, so that'll do. Which means that on our events we should be able to just add a we don't have. Okay, let's go add the event first. Move, void on look, and that is blah 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 blah. Wow, okay, fun times. Alright, we're going to take this out. Oops, not that piece. That piece. And we're going to enable this back to speed. And we're going to remove the maximum speed. But we may need some constraints on the we'll have a turning speed. I feel like this is still a bit fast. Let's make it like 10 and let's see how that behaves. And we are going to add a whoopsie serialized field private float turn speed is fine. Okay. And we are going to say when we are looking, I don't think that the context contains doesn't contain that, so it's going to say no, this is going to be look direction, field for look direction, which is cool. I'm going to log the look direction and call it look direction. Okay, alright. And just because I don't like things being all mixed up, I'm going to do that. And we're going to do that. Okay. Right, no, don't be naughty. Okay, and so private bool is looking. No. Whew. Shit. Okay. I have no idea. You can still look even when you're not moving, so we're always going to look, and we are going to say rb dot rotation in the y direction, and you're saying it's the x-axis, which is correct. And then we actually need the camera. Let's just first do turning, and then we'll get to the camera. Then we'll get to the camera. Because we want to turn the rigid body, otherwise you won't be moving in the direction that you're looking, which is what I want to. I want to be able to move in the direction that I'm looking, so turning the actual rigid body as you're looking. Okay. It's not doing deadly squat, right? Yeah, it's not doing anything. Of course it's not doing anything. What did I forget? I forgot to add the look callback. Okay. Let's go get my... I wonder if I can move it up. Move up. Okay, good. It's easier to work with you when you're above my player controller. Okay, now. The FPS controller. Okay. What did I do? What did you do? Did you make it private? Yes, you made it private because you're a fool. Okay, let's just go in here. Come. Make me no longer private. Come on. Oh, repainted the toolbar, really? Onlooker. Okay, let's see if that works. I'm gonna have to make sure that it doesn't go completely balmy on me, and it needs to stop turning when the mouse isn't moving. Ooh, very fast, very fast, very fast, way too fast. But that part is working, and that part is working. So I think the walk speed is too fast and the turn speed is too fast. Okay. So let's go in here and turn times speed. Okay, do we want to just add time dot delta time? And then that should slow that down, and let's change our speed. Oh wait, okay, I've changed it to here, but it's not right. Never mind. Being an idiot is sometimes hard. Okay. I'm making that 10 so it doesn't go completely balmy on us. It's a little bit slower. Okay, turning. Okay, moving. Whoopsie. I feel like I'm a bit high. What do you think? I feel like I'm a bit high, eh? Because I'm walking right into Eve at like kind of really high height. I should maybe bring that camera and everything down a little bit. What do you think? But look at that, we have a first person. Oh shit, okay. That's not good. Why did you not change the forward vector even though you rotated? Oh, look at that. It's not. Come on. Okay, so there's still a couple of little bugs. It's not changing the forward vector when you have. It's still moving way too fast. When you actually rotate it, it should be going in the direction of the rotation. It's weird. Huh. Okay, so little bugs still left, but I feel like that was pretty good progress for hour and a bit of trying to write a FPS controller with pretty much from memory and not knowing a hell of a lot of what I was doing. So I'm going to call it a night on the stream there, and I do appreciate the viewer that I have on Twitch. I don't actually know. Oops. Just do this and see. Hopefully I don't think there were any chat messages. I hope there weren't any chat messages that I may have missed. If there were, I apologize. Thank you very, very much for joining me on my journey to getting my assignments done for uni, and I do hope that you have a great 2024, and that all the craziness in the world starts chilling out a little bit soon. So have a fantastic rest of your day or evening, and I'll catch you next week.